Hey guys, it's Kirk from the Prepper Homestead. So today we are going to get the outdoor wood boiler tied into our heat system, so follow along. Alright, so we're down in the mechanical room. It's kind of tight quarters down here. It needs a good cleanup, but we're going to get the outdoor boiler that you kind of saw in the last video there. I'm going to get it tied into the heat system so we can start using the wood heat instead of propane. A quick little overview here. So if you remember from the last video, this is the heat exchanger that goes from the that comes from the wood boiler. So in case you wonder how hot it is, I was in the mechanical room the day I fired it up, and there was like a funny noise coming from around the heat exchanger area. So I bent down to hear if it was coming from the heat exchanger or whereabouts it was, and my neck hit the pipe and burned it. I could not hear the noise anymore over the screaming that I was doing. It was pretty hot. Anyway, hot. Do not touch. So what we're doing today is, I've decided I don't like the way this is. So over the next day or so, I'm going to have to go out and get some plumbing parts, but I'm going to put 90s on here, and then extend this down from those 90s with PEX pipe, so I can mount this further down in that little area there. So if I run some PEX pipes down, then these will be long enough to get in there. And then that basically puts me in a place that's more in line with getting 1-inch pipe. These stuff will all have to move out of here. 1-inch pipe, just like the top two there. There's going to be two down below there that go around the tank and connect in. I know it's dark back here, you probably can't see, but basically mimic this just down on the lower one. So there's a hot and a cold, and then down below there is another hot and cold that we're actually going to be connecting into now. There's one there and then one down below. And we're going to do the same thing with those. Alright, so end of day, I've kind of been back and forth on plumbing. I've gotten as far as I can, which isn't actually too far. I've just been using the stock, or plumbing parts from my own stock, just from the house build. So I've run out of a couple of key components, but basically I've got the top one. I know it's dark back in here. I've got the top one hooked up, goes off on angle, comes down here. Basically now at this point I need to put in a how does this go? Need to put in a one-way valve, or a check valve here, and then we're going to add a shut-off valve, and then a spout for a temperature and pressure gauge. At that point it will connect into, when we move this down, it'll connect into there, and then we have to do the whole return side. So again, coming off of that, we need to have the isolation valves for the motor, or sorry, for the circulation pump, and then wrap around and connect into that lower side there still. Okay, so we made a bit of progress today. I moved the heat exchanger down. I've added some 90-degree bends to where the pipe comes in. So I just need to add a short piece of PEX here and connect this onto there. Actually, I might have a better solution than that. Yeah, anyway, so there's short pieces of PEX, or I might just actually have a small coupler there that I can add for this side. And then there'll have to be a PEX there as well. So that goes into the heat exchanger. Again, it's moved down so I could hard plumb it right in. So this is the, what is this? This is the, well, that's good for those. So this is the return of the, so this is the hot coming out of the tank, going into the heat exchanger, and then it'll go back out. Down below, there'll be the circulator pump there, and it'll tie in. So I've got this line done. So basically it comes off the tank, comes here. We have the protection here for overheat. I always have a bucket sitting underneath this. This is the overflow for or over the heat. The name is escaping me right now. So this is for oh my gosh, so the thermal protection. That's it for the buffer tank, and then this is for that heat coil itself. There's always a bucket kind of sitting here, so it can, if it does spew out, it spews hot water into a bucket, not all over the floor. There is a shut-off valve here for this loop. That'll help purge the air out of it. Then I have a pressure and temperature gauge onto the so show the pressure in that loop as well as the temperature of the water there, and then the boiler drain valve here. Again, this helps to when it comes to purging the line and stuff like that. So now I have to do the other side here. This one has a little bit less equipment in it, so it'll have, actually I guess it's about the same. It'll come off, it'll have another boiler drain on it to help purge. There will be the circulator pump and also an overflow tank. Unless I could put the overflow tank back there, might do that. Anyway, so there's not an overflow tank, an expansion tank, smaller than that one, just a little 2-gallon tank, and then the circulator pump will run back in over to here. Of course, like every time I do plumbing projects, it doesn't matter how much stock I have on hand, I'm always missing something. So I need to get a couple more things. It's such a pain because it wastes half a day to have to go into town. The joys of small town living. But anyway, I'll pick some of that stuff up tomorrow, unless it's supposed to be sunny, and then I'll be out cutting firewood. I don't know, we'll see how it goes, but I'll pick up the parts I need, and we'll get back at it tomorrow. So the heat system, the radiant heat system, has been working for a couple of years, and back when I installed it, I made a error that didn't really affect the system too much, but you know, longevity wise it probably would. So this fall, before we turned on the heat system, I made a change to it to correct a problem, but it created another problem. So I'm going to fix that today and get everything turned back on. Basically, back when I designed the system, there's these thermostatic valves here. You see them on your hot water heaters a lot. So basically what it does is it takes the water, so our system here, the water gets pumped up here, and then goes through the circulator pump and out to all the zones. The problem is, the way I had this hooked up before, this valve was up there, and the pump would push the water through it, and these valves don't work that way. These valves have to have the water sucked through it in order for them to function. The way this valve works, so the hot water that comes from the boiler comes up through here and then goes out here. But you can regulate the temperature of the water going through the system, because like right now the boiler is heating water to 168 degrees, and this is based on the temperature outside. So this one changes, but you want the water going through the radiant heat to be about 120, 130, somewhere around there. So the way these valves work is, so the hot water comes through here, you can set the temperature of the water coming through the valve, and it regulates that by drawing cold water in to make sure it's at that 120, 130, whatever we set it at. So the cold water is actually coming from, like, as the water goes through the system and it comes out the cold and it goes back down and goes through the coil on the buffer tank and then back, the cold water from this is actually the return water. So it's actually the water that's going back to be heated up again. It actually draws cold water up and through the valve. So that should all work. The problem is, and I kind of wondered if it was going to happen when I did it, the way this cold water comes up and around, it doesn't seem to matter what I do, but it actually creates an airlock. So there's air stuck up in this pipe here, and it kind of makes sense because as as you're flushing and filling the system, I can never seem to get this water out of here. You can always hear this trickling, which means it's not pulling in the cold water. In fact, I woke up last night and I could hear this pump, so I feel like this pump has air in it. So I'm really hoping it didn't get damaged by drawing air and not water through it. I hope it wasn't too long before I woke up. I'm a pretty light sleeper, so anyway, what I'm doing today is adding a an air trap up here. So I'm going to have to cut some of this out and redo it, and that's going to allow air to automatically escape here. So I'm just draining this line, and then we will see if we can, what's going to have to happen to replace these pieces here. All right, we are getting close. So the circulator pump is installed. I still have to flip, so the flow is going the right way, but I have to flip it, undo these bolts, or I have to undo these hex bolts here and flip this around so the electrical's on top. This is for the home automation system to hook into. I don't have the thermal well yet, so I just put a cap on it. I have to install the boiler drain, or the boiler drain there. And then this one here is going to hook up to this small expansion tank. I just finished this crazy connection here, and all of the it's all hooked up to the outdoor now. So it's almost time to fill it and pressurize it and test for leaks and all that, but a little bit more to go here. All right, so we are hooked up, hopefully. Everything seems to be on now. Got our expansion tank. This big one is for the whole house radiant system, but because this is on its own closed loop, I added a small expansion tank for that. And then this tank is just our RO water. It has nothing to do with the heat. So we got the heat exchanger hooked up. Got our valves, temperature and pressure gauge, motor. On this side we have it going in there. You can see maybe you can see the two pipes that are coming out there. That's hooked into the same loop, but it is to hook the wood stove up, our indoor cook stove. It's got a heat exchanger as well, but that'll be hooked up in another time, so that'll be a whole separate video. Basically, I just ran those out of the way there. There's a couple shut-off valves. I don't know, you might not be able to see them. Got a couple of shut-off valves there. I just wanted to get them installed so I could put the brine tank back in place there. So yeah, I'm going to go through now. I'm going to tighten everything up that needs to be tightened up, check all the connections, hook the motor up properly, and then I'm going to, and then at that point I can go reflood this part, and then fill and flood the new part here, and also maybe clean up a little bit so I don't keep tripping on everything. Alright, so things are looking good. The outdoor boiler is running. I just lit it up about half an hour ago. I think it's at about 110, 120 right now or something like that. This green hose doesn't actually stay on there. I just used it to pressurize the second loop. So I'm just going to make sure it stays at pressure. And then, yeah, that could be just disconnected. So this circulator pump's running. It's going to be hooked up to the automation system, so it will turn on once the supply, basically once the boiler gets up to 150 degrees, or the wood stove gets up to 150 degrees. Once that component is added in, this pump will turn on to circulate through the buffer tank. So the wood stove and the heat exchanger from the outdoor boiler both heat the bottom half of this tank. Well, actually the whole tank, but it starts at the bottom, whereas the boiler, the gas boiler, only does the top half, so the bottom is always kind of cold. So what's going to happen is when the home automation system sees that it's 150 degrees coming in, it's actually going to disable the start on the gas boiler. So the gas boiler won't turn on until, or once there's temperatures of 150 degrees going into this buffer tank, it'll disable this boiler. So technically, the automation should disable this boiler pretty much all winter. But I'm going to leave it hooked up, so if we go away and temperatures drop below whatever, it should be below that 150, probably about 150, then the boiler can fire up. Everything's good on my copper stuff. There's water there because I forgot to close a valve, but nothing's leaking back here. There is a small leak coming from, I don't know if you can actually see it, right in there. There's a very small drip that it started after I fired this thing up, so now it's too hot to actually touch. It's not actually dripping a lot, so I'm going to let it run until the boiler is down in temperature, and I can touch these things again. And then it won't be too hard to fix. I just have to take off this the flexible line here, this section here. Basically, I'm going to have to take off this 90 degree. I tried to tighten it by winding that one backwards, but the Teflon tape is wrapped a different way, so it's actually just loosening up the tape. So I'm just going to have to do it the proper way and take this off, put new Teflon tape on, and redo the whole thing. Of all the places to have a leak, that's a pretty easy one, so not too worried about that. So as far as the heat system goes, we're much better off than we were at the beginning of the year. I am going to, within the next week or so, get the wood stove also hooked up to this buffer tank, so we can use that heat instead of the boiler as well, instead of the propane boiler. But there'll be more about that next time. Until then, have a good one.